Well, welcome all. I'm Kathy Mykleby. I'm a local journalist with a television station in Milwaukee, WISN 12, and I have a great appreciation for science, so I couldn't be in better company. And I also love the idea of anything that brings people together. And this event is indeed inspired by the love of science around the world. From the Dutch city of Groningen,
correct,
all right, to the Wisconsin city of Milwaukee, correct. All right. They are known for riding bicycles, those two-wheeled things that you pedal with your own feet. We have our Harleys, which is something else. But both cities are surrounded by industry and farmland and an appreciation of the old world. Groningen and Milwaukee are proud to have campuses and faculty dedicated to scientific expertise. Our panel today, our distinguished guest, Dr. Bernard Feringa, who is the Jacobus van Hoff Distinguished Professor of Molecular Sciences, Stratingh Institute of Chemistry for Chemistry at the University of Groningen. And among his honors, well, this is tough, Professor Feringa was awarded the Nobel Prize in Chemistry in 2016. That's pretty wonderful in itself, isn't it? And Dr. Marija Gajdardziska,
yes,
pretty close, Dean of UWM Graduate School and Professor in the Department of Physics. And Dr. Douglas Stafford, Director of the Milwaukee Institute for Drug Discovery and Executive Director of the Shimadzu Laboratory in UWM's Department of Chemistry and Biochemistry. I should point out that the lab is behind us and it's exceptional. It is fitting that this panel is meeting at UWM, a Tier 1 research university ranked among the best nationally and a key contributor also to home to Milwaukee's intellectual entrepreneurial vitality. Importantly, UWM works hard to make research approachable, which is also, I believe, what Dr. Feringa is all about, so that it can be an inspiration in science learning, and it'll increase science literacy for virtually everybody. With this in mind, our goal today is to get deeper insights into scientific inspiration and the impact on science learning. And I get to ask the first question because I get to lead this discussion. Keep the molecules running in the right direction and get much done in a short period of time. On the scale of discovery, I worry a little bit that people are thinking there's nothing to wonder about anymore. But really, in your regard, if there were a scale of, say, nano to 10, where are we in discovery these days?
I think we are at nano, of course.
Right.
We just scratched the surface. If you think the possibilities of science, what we have learned over the past 100 years or 150 years, and what we are heading towards, it is absolutely fantastic. There is a whole world in front of us that we have not discovered. We have to go beyond the borders and to go in this unknown territory where we can discover. It's amazing what is still possible, and what will be possible. You will see amazing, amazing discoveries in the years to come.
Along that line, you made a comment some years ago that nature provides all the inspiration that you need when thinking about science. How do we connect young people with nature and to get that inspiration?
Yes, now I grew up on a farm as a small boy and I got inspired by nature a lot. But think about Mother Nature around you and then try to translate it into the world's problems that we want to solve. And I use always this example, as I will do this afternoon. We look at the flying bird, and the Wright brothers did, slightly over 100 years ago. They were able for the first time to fly. And now we have the Boeing 747s. I came with this big plane here. It's completely artificial. The flying principle is completely distinct from the bird. We admire the bird, but for the purpose of carrying 350 people from Amsterdam up here, it's better to have a Boeing 747, and it works perfectly well. Although we also have to be modest, talking about what we don't know, we cannot build a bird. We cannot build a single cell of a bird yet, or a part of that cell of the bird. There is a lot to be invented and discovered. But yes, admire the beauty of Mother Nature and translate that in concepts of science, and then we will move forward.
So you mentioned that you were born on a farm, and I actually saw that in Wikipedia, on your Nobel presentation. It really is very important and very meaningful because the University of Wisconsin-Milwaukee is a top-tier research university, but our mission is also to provide access to students from all walks of life. We have a lot of first-generation students, students from underrepresented minorities, and we're always trying to figure out how to engage them in science. What is the right time? Is it the undergraduate research experience? Is it that master's thesis, doctoral dissertation? So what really got you hooked to science, and what works for you to get other people engaged in science?
Now that is a very important question. I think first of all, you mentioned it, I'm also from a rural area. My parents were farmers. We got the opportunity to study, and I think it's really important that everybody has a talent, that he can employ his talent and go into studies. In high school, I had excellent teachers, and that helped a lot. Then I entered into the university, into chemistries, and I was fascinated by the wonderful world of chemistry. You know, the colors, the smells, the beautiful molecules that you can design. And the fact that in chemistry, unlike many disciplines, you can design your own molecular world. Think of the new drugs that are also developed in this department. To encourage students in this way to go into studying and asking questions about what is possible, etc., and to learn, I think it's really important. This creativity that is so common to the natural sciences, and to stimulate questions and ask about Mother Nature, I think that helps a lot. And it's our task as teachers, because I feel it like that.
You need a reality show.
We should
Like
stimulate young people.
Some kind of a reality show with scientists living in the same room,
Yeah,
coming up with all kinds of,
maybe.
right.
And it's a lot of fun, Science is a lot of fun, and it's beautiful. I feel often like an artist. Isn't it beautiful? When I made my first molecule, I often tell this story. I got so excited. I felt like making a piece of music or a piece of art.
But you mentioned teaching, and I'm sure through your career you've experienced some outstanding teachers. What makes a great teacher in science?
I think somebody that can make clear, the basis of your topic, but also can go beyond that and put it into the proper context, and also set you thinking. That you, as a student, are going to ask questions. Because also a teacher doesn't know. I mean, what we teach, of course, is the state of affairs of sciences at this moment. But that is based upon our experiments, on our models, on our calculations, it's our insights that we have now. That doesn't necessarily mean that we couldn't go beyond that. And I think we should train our students to go beyond the stage what we know, the current knowledge, because our destiny at the end is knowledge, inventions, discovery.
Engagement, I kind of hear.
Yeah,
the professor just doesn't stand up in front of the room and tell you, this is what I did, I got the Nobel Prize, this is what I did. You want to engage the students to sort of communicate with you and back and forth? Or?
Absolutely. What I do is, the door of my office is always open when new students come in.
Yes.
I encourage them to discuss, and I say, look, we have some ideas about a project to work on, but you are all extremely talented because you are here at the university and you are at the beginning of your career. Please try to be better than I am.
Spread your wings.
And spread your wings. I try to challenge them and say, look, please use your talents.
For our undergraduate students, we put an awful lot of effort to provide an authentic research experience.
Right.
In fact, it's a requirement in our chemistry department. And it seems like there's nothing quite like being the first person in the world to have seen something. When that result comes out of plate reader, you are the first one in the world.
Right.
And isn't it part of a teacher is to inspire students for what discovery is all about?
Absolutely. This feeling of discovery. I think what you see when you have small kids, even in kindergarten, you have the small kids, and I go to schools now, elementary schools, to talk with them, and you see this beautiful glow in their eyes when you talk about small discoveries, etc. It's wonderful, and I think we should stimulate that kind of attitude of thinking, being critical attitude, but also the joy of discovery.
Yes,
it's really important.
Yes, nothing like it.
Well, you push graduate school, though, right?
Oh, yes.
Right.
So I'll ask you about the big kids.
Yeah.
The real secret how we got you to come to UWM is that one of your scientific children, one of your PhDs, is a professor now here in the chemistry department at UWM. So how important are your doctoral students for everything that you do and for the process of discovery?
I mean, when I got this call from Stockholm, which is like a boy's or a girl's dream, of course, I got the first thing I realized and I mentioned in public is this is the work of the whole team. All these generations of students, undergraduate students, graduate students, PhDs, everybody in the lab that together make this possible. And it was, of course, a work of several decades because these were complicated problems that we had to work on. But it's the work of everybody. Everybody put in his or her talent to make this possible. So I own a tremendous grateful to my students who made this all possible. And it was a joy to work with all these young talents to be able to reach this and to do this. And there were projects that were not easy. Recently we solved a problem that we had been working on for 20 years. Imagine, that's five generations of PhD students, because a PhD in Holland is 4 years, 5 generations that constantly worked on it, and finally we got the breakthrough. So sometimes it needs perseverance, it needs also to be a bit daring, of course, and to challenge each other. The students challenge me a lot, and that's really great. I enjoy that.
Yes, it's got to be daring. And, you know, I heard, we have to ask, you get the call from Stockholm. What do you do when someone calls you and says, you've just won the Nobel Prize?
Yeah, that was very interesting. I was discussing with my students just in my office about a project that was a tough project, and my first reaction was a bit, who is disturbing me? And then
I can't believe this is a prank call.
And then I got this call, and I realized it was the secretary of the Nobel Committee. So I sent the students out in the corridor, and then after 4 or 5 minutes, he said to me, I heard, Dr. Feringa, are you still there? It's so silent. And I said, yes, I'm completely in a shock. And then I murmured something like, I'm extremely proud, of course, but I'm still a bit in a shock, you know, because it comes so unexpected. This is not something that you expect to get, of course, because you work in the lab with the students, you teach, you do your research. There was one occasion, though, that, because people ask me then, did you expect to get a Nobel Prize? Now, there was, of course, sometimes thought about, people mention in the field, this area might get a Nobel Prize sometime. But you don't really think about that because we do our job, we teach, we do research. One evening in 2011, I was called by a colleague from the United States who said, did you realize you were last night on American television? And I said, come on, you are joking. And he said, yes, you were in The Simpsons.
No way.
And a week before the Nobel Prize announcement that year, there was The Simpsons, and they had a bet on the Nobel Prize in chemistry and physics and math, etc. And so Murner from Stanford, my name and another name was that. Murner got the Nobel Prize in 2014, I got it last year. Well, I thought, this is the highlight of my career as a scientist. It can never be any better, being on The Simpsons on American television.
My goodness, well, and that does promote science too, because you know, you do see Bart Simpson writing that same lesson over and over and over again. I will love science, I will love science. You know, maybe you start there, I don't know. How fun is that?
Yes.
Well, you have managed to kind of bring science to, you're obviously a very down-to-earth person and very charismatic, but you have brought it to the level that others can understand, like me. I mean, we've got some brain power over here. I'm the kind of person who has to try to describe science to other people. Yes. You make it very easy.
Thank you very much. But I think it is really important that we as scientists do a better job to bring science to the general public. Even to the politicians, you know, and I don't want to talk about politics, but also in Europe, we get these questions, you know, about why is science so useful and why do we spend so much money? I would argue the best investment you can do is in your youth, because they will bring our society forward. Invest in your future, and that is by investing in teaching and research.
So can we go back to one of the things you've talked about as far as research and kind of these high-end projects? And you guys made some comments about scientists need to take risks. And I'm sure in your career you've taken many risks. I mean, you even made the comparison to the Dutch explorers discovering the New World. How can a young scientist take risks these days? How do they get funding? How do they get publications? How do they get tenure in universities if they take too many risks? How do you balance that?
Yeah, this is a really important question, you know, the balance between risk and... I always tell my young people, and I gave this advice also to Dr. Arnold, I think, when he started his independent career, or he was a PhD student, walk on 2 feet. So try at least to do something highly riskful. But if you work only on that feet, you might walk for 5 years and don't have any results. If you get a result, it will give you a name, of course, and it will give you your own field. But also walk on the other foot that you have a good balance, because you have also to do something that is maybe less riskful, but will give you solid results, will give you a grant, and will give you a publication, a couple of publications that you need to get tenure, etc., and to build the next steps. Because you cannot afford, certainly not these days, maybe it was 30, 40, 50 years ago different, but nowadays you have to show at least some result and that you make progress. And also the students deserve it, you know, because when you are a PhD student or a postdoc, and you don't get any publishable result, we have also the obligation to help our young people, our students, to make the next steps in their career. And so I always try to balance that, yeah? But certainly you have to take risk, because we go in an area or in areas where we don't know what is out there, yeah? That is research, no?
It's great to hear good news out of chemistry, but there can be bad news. I mean, obviously, you know, things can go awry. You can have spills, you can have bombs, you can have bad, you know. So what is it that the scientists, what do you hope from the scientists as far as, you know, sort of their approach to discovery?
Yeah, no, but obviously, as you are a chemist, we make all these products, from drugs to plastics to dyes. We know we use plastics everywhere. But there's also this problem, for instance, of plastics in the ocean, yeah, these tiny particles. We, as scientists, have a duty to take a critical attitude towards what we produce. We try to make our materials that we use in everyday life, being it in our cars or in our drugs or in our smartphones, as safe as possible, yeah, and produce it in a sustainable way. But of course, there are, like with many of the things, there are also downsides of it, and we better are aware and train our students and educate about these kind of things and try to find solutions. Yeah, like I see here, for instance, water treatment, or analyzing how much metals are there in wastewater, or what are we going to do with biodegradation of plastics, for instance. All these things are important, and this offers tremendous opportunities also for science. To move it forward. We should not deny it. We should take it as an opportunity, a challenge.
Yeah.
Because we have to do better in certain aspects.
Because once you discover something, you shouldn't give up on discovering something on a new level.
Of course
The Shimadzu lab here is working on asthma medication right now to try to make it easier, to try to make it faster and more effective. That's amazing.
How fantastic can it be, and how rewarding, and on the way to solve this asthma problem, which will help tremendous number of people, you might find completely different things that can help to solve other medical problems. So I think there's...
Yes.
I love serendipity. That's always fun. You know?
I mean, you sometimes stumble on something that you think, wow, if I had this, known this. This is also science.
Speaking of serendipity, in my work in physics, we discovered by chance a new material, two-dimensional graphene monoxide, essentially CO in a solid form. And normally we publish, we give presentations, but these days at universities there is also an emphasis on patenting, on doing startup companies, and also preparing our students when they get their PhDs, their masters, their bachelors, to not only look at positions in academia or national labs, but also look at companies or even start their own companies. So in your life, you were at a company and then you returned to a university. What is your sense about the importance of having research in these multiple environments? And how are they to balance each other so that we're pulling in the good direction?
I think this is really an important issue in the whole academic environment. Of course, universities, the academic institutes have their own mission. We should do basic research and we should train students. But beyond that, there is a lot of opportunities to cooperate with industries, to look at societal problems, and this is also an important part of our duties. I have, during my whole career, worked with industries. I started even some startup company myself. I encourage my students to do that. I worked after my PhD 6.5 years for Shell, major oil company, and to me it was a tremendous learning opportunity to go out of the comfort zone of the academic world to learn how companies operate, how you have to make products and put them into the market, how to run a factory, I think you can learn a lot. So what I usually try to do is, at least at the master level, to send our students to companies for a couple of months, or to experience this different world. And when you then go back in academia, at least you get a flavor of, oh, when I work on this problem and I see an opportunity for application where we can solve a problem like in society, or make a new industry, or start a startup, I think we should encourage our students a lot. Because we cannot only rely on the big companies that have been always there. There is tremendous opportunities for new entrepreneurship and so. And a lot of these things come out of academia these days. So I think it is fantastic opportunities for the universities. And I see it here in Milwaukee. Yes. I see it also in other universities. I think, honestly, I think the United States is a little bit ahead of us with this attitude of entrepreneurship. You see it now also coming in Europe. But it's really important messages for our young people. Yes. It's not only about academic training. It's also about what is out there in the world.
Right. That's interesting. Milwaukee actually is the home of the invention of the typewriter. I just remember that. There's a street corner you go to and you'll say, Milwaukee is the home of the typewriter.
Also beer.
A little beer as well, yes. Beer too.
Just a little.
But you say that America is ahead in something, and that's pretty phenomenal for people to hear, because so often we hear, especially in sciences, that we might be slipping, that we're not pushing hard enough.
I cannot judge that. I mean, that is fantastic science. I mean, I see here also a great institute with cutting-edge science. In general, I would say what I have experienced over the past 25, 30 years is that the entrepreneurial attitude of young people in the United States is better, is present than in Europe. Now it's catching up in Europe, and we do put a lot of effort on startups. There are industrial parks at universities. People try to stimulate young people to start their own companies and so. But here it's more like an attitude. Start your own business. It's fine. It's great. Take that risk. Yes. And we can learn from America in that respect.
And I think that mindset is really part of what we're doing in the laboratory behind us, because we receive funding from the state of Wisconsin, so our regional government, with the notion of better connecting the university resources, both the intellectual capability as well as instrumentation that a small startup company could never buy, a triple quad mass spectrometer. And so I think that's really important for universities to have that as part of their mission, and that seems to be a little bit different from the traditional teaching students, rather than being a supporter of economic development and kind of the industrial vitality of a region. I think we try to do that.
I think so. Now, if I were doing a story about this right now, I'd ask you, for crying out loud, describe what a wada does, in real life.
Yeah, but I fully agree, that when you can build these facilities and then have really state-of-the-art, where it's big investments that a small company never can do. Right. But then you can use this as a kind of a breeder facility for several startups, or connect with local industries, etc. You will benefit from both sides, because to maintain such a facility is also expensive. So if you team up then with small industries or with major industries, you can then together invest in the future. And I think it is a very good model,
Yeah, and I think too, as our students understand how industry works.
Absolutely.
And so both wheels are turning at the same time, and I think that's important. They can get a little bit of a taste. Maybe that's the direction they want to go, as you went to Shell.
They get the contacts with industry. They then learn about how to approach things, which is often a bit different from what we do in fundamental research, of course, and there are other parameters, to develop a product. Yes. We all know a product to the market, that's a bit different game than only working on fundamental science. So the students can automatically learn a lot from that, and so I would say it's a win-win situation.
When did the flip switch for all of you? Like, when do you think you went, oh, science is just awesome? How old were you? What was going on?
I was always interested, in asking questions, and in this bit of an adventurous, uncertain thing. When I worked with, as an undergraduate student, I did my research, first small research projects. I had an American professor, by the way, trained in America, and he gave us tough problems. And he said, we want to compete with the best schools in America. That was a good driver for me. And then I remember that I made my first molecule, and I came to the office of the professor, and he said, this molecule has never been made before, not even in America. And I was so excited that I made a molecule. It was an absolutely useless molecule, but I was so excited. Like, this is my piece of music.
Absolutely.
I made this for the first time.
That's awesome. How about you, Marija?
Oh, for me, I think definitely high school. But the real moment which set me on the trajectory for sure was an undergraduate research experience. I got to go to Grenoble, France. And that's a city for physics and for skiing, and I love both of those things. And having that experience when you're working on real science, something where even my professor at that time, Jean-Claude Pépé-Perula, his PhD advisor had a Nobel Prize in atomic physics. So I worked with somebody who was one step removed from a Nobel Prize, just like people who are working with Alexander Arnold here have that connection. And working alongside on something that even he didn't know what the answer would be. So doing something that nobody in the whole world knows what the answer is to. It's not at the back of any book. And I think that's like the biggest privilege you can have as a human being.
Right.
It just is.
It's almost better than falling in love. I don't know. How about you, Doug?
My answer is very simple.
Yes.
When I was in college starting off, I had some really great teachers. And that's what we talked about, teachers and being inspired. And I just thought, I want to do that.
Yeah.
These people are in total control of the field. They love what they're doing, and they love being with students. And what could be a better thing to want to pursue as a career? So it was really an inspiration by teachers.
Yeah, and this excitement, you know, of maybe making a discovery, something that nobody has done before. And I fully agree with you. I consider it a privilege. Yeah. I consider it a great privilege that I've worked my whole career with the most talented, bright, young boys and girls in the world. It's fantastic. And you have a family all over the world, by science is everywhere.
So is that what you're doing with your science now, traveling the world, or are you still in the lab?
Oh, we have a big group working in the lab, and I hope my boys and girls are working and still get very excited. We do cool things there. But yes, I travel quite a lot. I go to schools and so to talk with children. There's a lot of demand now, but I enjoy it. And as I said before, it is a great privilege.
Well, I'd love to talk
with.
for hours, but I think we have to.
I think
Go
we
to the real
actually
lecture.
have to go to the real lecture. And in my business, we call chemistry like the sort of energy that's between the people doing the news and the, jumping out of that box with the glass in front of it into people's homes. I'd say we got some chemistry going on here. We should take this show on the road, but you've got another event, so what a pleasure. Thank you.
Thank you.
Thank you.
Thank you. My pleasure.
Oh, it was
Thank you so
wonderful.
much.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. My
Thank you.
pleasure. Thank you so much.